Hello everyone, in this video let's discuss how to solve the modulo k problem. So the given question is DFA to accept the string of even number of A's, that is 2, 4, 6, 8, 0 like that. So we will be solving two problems related to modulo k problem in this video, so you will understand perfectly. So to solve this problem we will be just using the 5 step. The first step is to identify the number of states. Here, since the question is telling, we must draw a DFA that will be accepting the string of even number of A's. So its complementary will be odd number of A's. So we will be taking two condition or two cases. In case number 1, it will be even number of A's. So I will be representing it using E, that is capital letter E. Now the second case is odd number of A's. Odd number of A's. So let's represent it using capital letter O. So we are representing the even number of A's using the capital letter E and odd number of A's using the capital letter O. So this is the main step in solving the problem related to modulo k, because if you are not perfect enough to identify the states, it will be the wrong answer. So you must take the complementary situations also. Now let's move to the second step. The second step is to identify the start and the final state. So here we are having only two states. So the number of states are 2 and the one state is capital letter E and another one is odd. If I start with the even state, when it will be encountering the string which is having even number, so it will stop here. That is, the initial state will also become the final state. So if it will not, means it will go to the odd and again I will add another A to that. So it will become E. So here if you look, you can conclude that the initial state E will be the final state also. So initial state and the final state. So both are capital letter E. Now the third step is designing. So how to design means, the first scenario is do of capital letter E. That is, if you have encountered capital letter E means even number of A's in that string. So if you want to convert it to odd numbers, you will add another A to it. So it will become odd. If in another situation odd number of A's are there, what you will be doing? You will be adding another A so that it will be becoming capital letter E. That is, it will be becoming even number of A's in that string. So these are the two situations we can use to design the DFA. So in the fourth step, so what we will be doing is, we will be just representing the tuples which are being used in the DFA. Here if you see, we will be representing the DFA, that is deterministic finite automata, using the 5 tuples. First one is Q, which will represent the number of states. Summation, that represents the input string which has been used to move from one state to another. Do, that represents the transition states. Q0 is the initial state and F is the final state. So now let's write all of them. So if you see here, Q means the states which has been used here. Here we are using only two states, capital letter E and capital letter O. Next, summation. So summation means what are the input string we are using for moving from one to another. If you see here, if I want to move from odd to even, I will add one A. If I have to move from even to odd, I will add another A to that. So you can conclude only A is the input string which has been used to move from one state to another. Next one is do. Do has been already written here in the designing, so no need to write it again. Next one is Q0, that is the initial state. We know that initial and final state both are capital letter E. So you can write both are capital letter E. Now you came to the final step, that is drawing the DFA diagram. So you know the initial state is capital letter E and you also know that the initial state is also the final state. So it will be enclosed using the 2 circle. Now if I add one A to the even number, it will move to the odd number. If I add one A to the odd number, it will become even number. So this cycle will happen, and whenever the string is having even number of A's, the string will be accepted. So now let's solve another one question, so you will be understanding much easierly and perfectly. So this is the second question. What it is telling, draw the DFA to accept the string of L, that is the language, w/mod 3 will be equal to 0. That is, if you divide by the 3, it must be equal to 0. Then only the string will be accepted, where summation, that is the input which you will be using, will be only A. Now let's solve using those 5 steps itself. Step number 1 is identifying the number of states. Identify number of states. So we must take all the scenarios. If I want to divide using 3, if it is a multiple means, we will be having 3 cases. So case 0, case 1, case 2 I will be taking. Because if you divide by 3, then the remainder may be 0, remainder may be 1, remainder may be 2. So 0, 1, 2. If you divide any of the number, so it may be anything. So if you divide any number, its remainder may be 0, 1 or 2 when you divide by 3. If you divide by 5 means the remainder can be 0, 1, 2, 3, 4. If you divide using 7, so the possible states will be from 0 to 6, like that. So since we are dividing using 3, the condition will be 0, 1 and 2 with the remainders. Now let's go with the second step. The second step is to identify the start and the final state. So start and final state. So here the first scenario is when you divide, if you get the remainder as 0. So here I am having the 3 states, that is 0, 1 and 2. If 0 is encountered at the starting only, that is the initial state only, then you will stop the process there only. That is, the initial state will become the final state itself. So you can write like this, the initial state and the final state. So both are 0. Now let's move to the third step. The third step is designing. So here we are having 3 scenarios. We must write according to that. Do of Q0, because I will be taking this one as Q0, Q1 and Q2. So you will understand much easily. So if I take this as the Q0, that is the initial state Q0, and if I add one A to that, here if you see the input string is only A here. The input string is only A. So what I will be doing, I will be adding one A to Q0. So where it will move? It will move to Q1. It will move to Q1 because when the remainder will be 0, if I add another 1A, the remainder will be equal to 1. Now do of Q0 comma. Now Q1 you must use here, Q1 comma. If I add another A to Q1, what it will become? It will become 2 remainder, that is it will be equal to Q2. Now do of, if I add another A to Q2, if I add another A to Q2, it will become 3A's and it will be divided by 3. So it will again go to Q0. So if you see here, 2 remainders for Q2. If I add another 1A, it will be 3. If it is divided by 3, it will be equal to 1. 2 plus 1 will be 3. 3 divided by 3 will be equal to 1 itself. Now we wrote all the 3 possible do or the transitions table. Now let's move to the fourth step. The step number 4 is to write the 5 tuples of the DFA. First one is the states Q, summation, that is the input string that you are using. Do is the transition table. Q0 is the initial state. F is the final state. So here Q means what are the states you are using? Q0, Q1 and Q2. Q0, Q1 and Q2 are the 3 states we are using here. Next, summation means in the question only they have given, you must use only A as the input string. Next, do is already written here. Initial state Q0 is 0 itself. So here I am representing 0 using Q0. So I will write Q0 itself. And the final state is 0 itself. So you can write Q0. Now, if I want to draw the DFA diagram at the last step. So what I will be doing? I will be starting from the initial state Q0. And it is also the final state. So I will enclose it using the 2 circles. If I add 1A to Q0, it will move to Q1. Next, if I add 1A to Q1, it will move to Q2. If I add 1a to Q2, it will move to Q0 again. So the final state is conserved. So we solved two problems related to modulo K problem. If you have any doubt regarding this topic, please do comment below. I will clarify it. And if you liked the video, please subscribe and support us, because your one support motivates us to make more engineering related topics. Thank you.